What's up, guys? Michael with Michael Talks Metal back for more Martensitic machinations in our second part on Martensitics. In our video last week, we talked about Martensitic types that have a maximum carbon content of 0.15% and maximum hardness of about 40 RC. And if you did not check out that video, there you go, a little card, click there. Take a look. Higher carbon contents allow us to achieve higher hardness and strength with heat treatment. Higher chromium and other added elements can improve corrosion performance and or mechanical properties. First up today are several alloy grades that are small modifications of the chemistry we saw in Type 410. They have similar applications but are utilized where 410 is not quite satisfactory. Type 414, 0.15 max carbon, 11.5 to 13.5% chromium, has nickel added at 1.25 to 2.5%, which improves its ability to harden and adds toughness that makes it more useful in the low 40s RC hardness range than Type 410. The nickel also improves corrosion performance in some environments. It also improves mechanical properties at modestly higher temps as compared to Type 410. Type 431, 0.20 max carbon, 15 to 17% chromium, 1.25 to 2.5% nickel, has improved corrosion performance from the higher chromium as compared to either 414 and 410. Type 418, aka Greek Ascalloy, 0.15 to 0.20% carbon, 12 to 14% chromium, 1.8 to 2.2% nickel, and has 2.5 to 3.5% tungsten for higher strength at elevated temperatures, above those where 403 and 410 are used. Jet engine or land-based gas turbine applications would be examples. Type 422, 0.20 to 0.25% carbon, 11 to 13% chromium, 0.5 to 1% nickel, 0.75 to 1.25% molybdenum, 0.15 to 0.3% vanadium, and 0.75 to 1.25% tungsten. That's a lot. All right, so this is also used for the complex requirement at elevated temperatures. Right? So next up is a type that could easily be considered its own group of alloys. Since Type 420 is broadly defined as 0.15 min carbon, 12 to 14% chromium. First time we've encountered a stainless alloy with carbon specified as minimum. We know how important the carbon content is in Martensitic stainless steels, so we can expect a wide variation in hardness and strength depending on the carbon content. Hardness can range from the low 30s to the middle 50s on the RC scale. In the most common composition, the carbon is in the range of 0.3 to 0.4% carbon. Common applications are in cutlery and plastic molds. There are also free machining grades indicated by the suffix F, like 420F. Always be looking for further specification that defines the material to assure the final product will do what it intends to do in service. Lastly, we have a group of alloys in the highest range of carbon in the Martensitic series, the 440s. Chromium content is 16 to 18% and has 3 variations with differing carbon content. The higher chromium content improves corrosion performance over Type 420 and 410, and the higher carbon increases the strength and hardness capability. 440A has 0.6 to 0.75% carbon. 440B has 0.75 to 0.95% carbon. 440C has 0.95 to 1.25% carbon. Hardness from the low 50s for the A variant, mid 50s for B, and they are commonly used in cutlery and similar applications. 440C is typically used at around 60 RC and used in valves or bearings and other applications where both corrosion and wear resistance are important. As usual, we caution viewers that chemical composition can be further restricted by specifications and add some important additional requirements. So for the 142nd time, I'm going to tell you to check, do it, the specs, right? Where are we, huh? Twice. Okay. This is Michael with Michael Talks Metal. National Metals is a full-service, value-added distributor of all things Martensitic stainless and more. Check the website for more info. Still here and haven't subscribed? Help consider supporting the channel. Thank you. This last week's, there it is. This is Michael with Michael Talks Metal. I will see you guys. Same time, same place, YouTube, 10 a.m. Thursday next week. I'm out.